Okay, hello everyone. So we will start the session since it is already 3:03. Um, yeah, and I advise everyone to during the TA session, which is from 3 o'clock to 5 o'clock. I advise everyone to mute your speakers, mute your mics, and switch off your video cameras since it might cause some um, extra interference. You can turn on your mics whenever a question is being asked to you, or you can turn on your mic when someone, in case you want to ask doubts or anything else. So we will get started right away. So my name is Arjun SV. I am a second year PhD student from Indian Institute of Science, Bangalore, and I have provided my email ID in this introductory slide. So if anyone wants to, you contact me in case of doubts or any other queries, you can address this email ID arjunsv@iisc.ac.in. So I guess some of you are new here compared to last week, where a different set of people attended this TA session last Saturday at 3 p.m. to 5 p.m. So can you all hear me? And I just want to know, can you all hear me and can you see my screen? You can either put this answer in the chat box, or you can,
Yeah, we can hear you.
yeah. Can you see my screen?
Yes, we can see your screen presentation and yourself.
Yeah, yeah, sure. Thanks a lot. Yeah. So yeah, I think, yeah, as I was saying, half of you are kind of similar from last Saturday's session, while some of you are near. So what I'll be doing through the session is I'll be going through a short recap of whatever the lectures we had over the week two, and I'll be having a short doubt session for 5 minutes, and then we will be going on to solve the problems that were posed for this week's assignment, and then towards the end of the lecture, I will be having another doubt session. In case if you have doubts before or after the problem statement, you can ask them separately as well. So we will move on to a short recap of the lectures that were provided in week two of this course. So week two of this course mainly focused on logical reasoning, and the lecturer Dr. Soumitra Banerjee started with categorizing logical reasoning into two categories. The first category being inductive logic. So inductive logic refers to the logical reasoning where a particular premise gives rise to a general conclusion. So we will have one or more than one a set of particular premises, and that will give rise to a more general conclusion. Um, some examples might he also cited some examples in this inductive logic, mainly saying that, for example, seeds germinating into plants, because let's just say we observe a couple of seeds, we put them into soil, and then we observe them growing into plants, and because a particular set of seeds grow into plants, we can conclude from this particular set that if we plant another seed into the soil, that will give rise to a plant as well. And one more common example that he provided, that is that all insects have six legs. And he also gave some other examples as well. And towards the end of inductive logic, the explanation of inductive logic, he told that inductive logic might not be used in almost all the cases in scientific reasoning, because of the fact that there are in almost all the cases, there are rare cases which violate whatever general premise we have. Sorry. Yeah. So, sorry. So, one of the examples by what he said, by rare cases which violate the inductive reasoning, is that the presence of some people having hearts in their right side instead of their left side, and some of the seeds or something like that not germinating due to poor conditions or something. So he was like, at not all conditions this happen, so you cannot generalize, come to a general conclusion that these things will always happen. So inductive logic, he said that inductive logic might not work in all these cases, but at the same time, he also explained some other cases where inductive logic is the only way to proceed. For example, he went on to explain in astronomy how using parallax method we used to find the distance of the stars or galaxies from Earth. So in that reason, a particular scientist called Henrietta Leavitt. So they found out some specific Cepheid variables which pertain to a particular planet or a star, and using parallax methods, they used parallax methods in the Cepheid variables. They were able to come to a conclusive evidence that the luminosity of the pulsating stars is directly proportional to the periodicity. The absolute luminosity and periodicity have a direct relationship. So through this relationship, they were able to extrapolate the distance of a star, and they were able to come to a apparent luminosity value, which gave them a value of the distance towards the star. And the experiments done by Henry Leavitt were also extrapolated by Hubble, yeah, Edwin Hubble, who was able to find the distance of the stars in Andromeda galaxy from Earth. And in inductive logic, our lecturer also told that there are two different types of inductive logic. One is probabilistic inductive logic, and the other one being deterministic inductive logic. And in probabilistic inductive logic, we come to a conclusion by saying that with a high degree of confidence, some conclusion is happening. So that is the way we come at up. That is the way we come to reasoning using probabilistic inductive logic. And in deterministic inductive logic, we say that until something else happens from whatever general conclusion we have, this is the convincing general conclusion that we have for now. So we are going with that. So that is the difference between probabilistic and deterministic inductive logic. And in the subsequent part of the lectures, the lecturer also started to explain about deductive logic, where deductive logic always means there is a set of general premises, and these general premises give rise to a particular conclusion. And one specific bifurcation of deductive logic comes through the introduction of modus ponens and modus tollens. So so deductive logic occurs in a case where if A then B, and if A then not B, then if not A then not A then B, and then if not A, not B, then not A. So there are several other ways by which statements regarding deductive logic could be made. Out of that, we discussed how only certain kinds of how certain structures of deductive logic can be possible and how certain others cannot be. So we went through the example of copper dipping in vinegar. So when a piece of copper is dipped into vinegar, then it is turning green. So that particular statement, when it is rearranged in some other ways so that it can be formulated into four different statements, such as copper being dipped into vinegar turning green, copper being green then turning into resulting in concluding that it is being dipped into vinegar, and copper not being green not being into vinegar. And such kind of statements gives us to the rise of modus ponens and modus tollens. Modus ponens tells us that if something is some A, if A then B, A is happening, so in conclusion B should also happen. So that is basically modus ponens. And in modus tollens, how the structure would be is, if A happens, then B happens. B is not happening, therefore A should also not happen. So if copper dipped into vinegar turning green, copper is not green, so it is not turning. So it is not being dipped into vinegar. That is the structure by which modus tollens is uh, deducted. And apart from modus ponens and modus tollens, we also have another bifurcation of deductive logic, such as probabilistic deductive logic and diffeasible deductive logic. In probabilistic deductive logic, we say that if A, then B, but if if A, then B does not always happen. B happens with a probability. The probability of B happening when A is there is called P. So this logical reasoning does not always happen. They happen with a confidence interval. That confidence interval is what we call as a probability, and we assign some random number to it based on whatever findings we have using the particular premises or particular set of experiments that we perform before it. And one example that we had with respect to probabilistic detective logic is the height of weight of mice. The weight of mice being lesser than or equal to 2.5 grams and being with 95% probability. And the other bifurcation of detective logic is defeasible logic, where there are a set of premises. The set of premises have one premise one will have a subject and a predicate. Premise two will have the predicate of um, the predicate of statement one, premise one as subject of statement two, and then there will be a new predicate and so on. All the premises will be linked together. So what eventually happens is, um, the all the premises will be compiled together, and whichever premise is stronger, there will be a set of premises which will uh, negate the conclusion of another premise. So premise one will say that if A then B, premise two will say that if C then not B. So to conclude among a set of such premises, we will subjectively we evaluate which of the premises will act strong. So if premise 1 is stronger than premise 2, then we will take, if A then B will be stronger than C gives to not B. So premise 1 will have a stronger influence on the conclusion than premise 2. On the other hand, if premise 2 seems to be stronger than premise 1, then we can conclude, then the influence of premise 2 on the conclusion will be higher than premise 1. And in the last parts of the week two's lecture, the lecturer focused on syllogistic logic. Syllogistic logic being one of Aristotle's way of deductive logic. And in syllogistic logic, Aristotle says that all deductive reasoning have a certain grammatical structure. Those have the grammatical structure meaning all the premises have some sort of a subject, some sort of a predicate, and some sort of a middle word. And all the set of statements leading to a conclusion will have some sorts of major premises, some sorts of minor premises, and some sorts of a conclusion. And in through Aristotle's syllogistic logic, we came to know that there are four types of reasoning. One being all A are B, no A is B, some A are B, and some A are not B. And after this, we also looked at representing anything through a series of Venn diagrams, how set of statements can be represented into Venn diagrams, and how proper conclusion can be drawn through interpreting those Venn diagrams. And in the towards the last part of the lecture, he also discussed about truth and validity of a set of statements, and he discussed about how if a a true premise can give rise to a true conclusion, and a false premise can also give rise to, a set of false premises can also give rise to a true conclusion. But a true conclusion does not necessarily mean that the premise is also true, and a false premise does not also mean that the premises are set of premises are all false in nature. So this is a short recap of what happened in the lectures in week two. So inductive logic, detective logic, probabilistic and defeasible detective logic, and syllogistic logic, and truth and validity. So now that I have covered briefly about week two's lectures, we'll go on to a short doubt session. And doubt session, as in, it will just be a short discussion form of a session. So I'll leave the room open for 5-10 minutes. If not, we'll go on to the problem discussions as the assignments for the problems. I also want to ask one small question. One question is that has any of you received the assignments for week two, and have any of you started attempting the answers?
Uh, Arjun, this is Bhaskar.
Yeah.
Actually, I'm staying in USA, and
Okay.
now the time is almost 4:30 a.m. morning. And I attempted for week two session,
Okay.
and in week two session also, six lessons are there,
Yes,
and
there are 6 video lectures, and there is an
yeah,
assignment having
10,
10 questions.
10 questions. Yeah. This actually these are the general type of questions. Five questions are general type, and all five questions are related to logic, like a whatever you said now. Aristotle is not a
Yes,
type
yes,
of
exactly.
structure.
So 5 6 questions will be statement based. So we will be having 3 or 4 statements, and then we have to draw a logical conclusion out of it. And other 3 4 questions will be just theory based questions.
Yeah, here my question is that actually we are week one also we have done the assignment, and week two also we have done an assignment, and next 10 weeks are there. And my question is that the exam will be like a theory type, whatever questions are asking, the theory type will be there, or it's like a whatever assignment it is showing same, like that pattern is same for final exam.
Um, one general, what to say, um, pattern that all the NPTEL exams would be following is they will have the similar type of questions to whatever you get in your assignments. So here we have multiple choice and multiple select questions, meaning that
Oh,
multiple choice meaning that you have only one option to choose from, or multiple select meaning you have multiple options to choose from out of set of 4 or 5 options. So whatever you are getting from here, those kind of questions will only come. So you won't be asked to write essays or theory based questions in the exam.
okay.
Yes, but you will also be. I think you will also get to know about the exam pattern a few weeks before the exam. Like the exam is on April 24, if I'm not wrong. You will get to know the pattern of the exam before that.
Okay, okay. Actually, I'm writing as a here. Actually, remote session will be there for us in
Okay,
USA.
okay.
Yeah, I hope that 2 weeks before I can get the uh, whatever pattern is there.
Yeah, April 27th is the exam date. My bad.
Okay. Thanks, Arjun.
Yeah, sure, anytime. So the reason why, in general, the reason why I asked this question, if people attempted the assignments, is I'll be going through a set of 10 questions. I just at either at the start of the assignment session, like as in 2 questions, in after I discuss some 2 or 3 questions, or after I discuss all the 10 questions. So people can, those who attempted the questions already, they could actually either comment in the chat box, or they can open their mic and tell that whether they have attempted the same questions or not. So because this is why I'm asking this, is because I received some feedback after last week's TA session saying that some of the questions that I discussed were not in their assignments as well. I'll leave. So, Mayuri Dongri is saying, can we discuss those questions here? I am going to discuss. So after this doubt session, like I'll close the doubt session after, up to 3:30 or something. Then we'll start discussing those problems. I'm going. The whole point of this TA session is to give you a short recap, clear the doubts, and then discussing over the problems that you got in the assignments.
Arjun, I missed the conversation for first session, whatever session we have for second week, and I missed it for first week session. How can I get the session, same session as a recorder or something is there?
So I think you will be getting the video links for the so you are asking you missed the week one's TS session, so you are asking the video links or recorded sessions for that, right? If I'm not wrong.
Yes, same session how you are doing now, same session for one week, first week.
Yeah, so we actually recorded those sessions and we uploaded them to NPTEL. So we sent them over to NPTEL. So if you look over the tabs of lectures in the NPTEL lecture, so you'll see the last column is problem solving sessions.
Okay.
Yes. So if you go there, you will find a Google Docs, Google Sheets kind of thing, where you will find the YouTube URL, and you might also find the whatever PPT I'm presenting. You will also find that drive link.
Okay, but here in assignments, it is showing week one and the six sessions and feedback session and assignment session only it is showing.
No, 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 not those ones. So the last, so after week 12, you will have something, some tabs.
Oh, after week 12, okay.
Yeah, after week 12. One second, I'll just.
Arjun, can we discuss week one questions, assignment questions, quick, like in 2-3 minutes? Because I missed last session as well. Uh,
Okay.
Rather, I joined the course this week. Uh, so we're already in third week. So first week uh, questions, is it possible to discuss them?
Um, I can do one thing. I can do one thing. Maybe we can go over this questions now, and if you have time in the end, around half an hour or something, I can go over the week one answers as well.
Sure. Did we discuss week two question assignments also?
I'm going to do it right now.
Okay, okay. And week three will be discussing next week, right?
Yes.
Okay, okay, excellent.
Uh,
Okay.
can can I have one question for you? So can you tell me when is your deadline for submitting the assignments for week two?
Week two and week one both are next week, 7th of Feb.
11th of Feb. Okay.
7th, 7th.
7th of Feb. Okay. Okay. Then. Okay.
Okay, we can discuss at the end. Yeah,
Yes. Sure.
thank you so much.
Rima Liban, sir, can you please differentiate this general to particular and particular to general concept in terms of the cloudy day and choice of taking an umbrella? And so, okay, so general to particular is pretty. So the inductive and deductive logic basis is pretty simple. General to particular and particular to general. And one second. So in particular premise to general conclusion, I think he would have said that this sky being cloudy and it will rain. That will be the example. So as a person, you just go outside and then you just see the sky for the day, and then you just see the sky for today. It would be pretty sunny. So what conclusion you would obtain from that is that it won't rain, because you have seen like throughout 18 or 20 years you have seen the sky, and whenever the sky is sunny, you wouldn't observe rain in that day. Whereas on the other case, if the sky is sort of cloudy or it is very dull, then immediately after 1 or 2 hours or half an hour, you will observe some form of rain. So whenever you see the today you see the sky and um, it's pretty bright, so you already have all those uh, particular instances of um the sky being cloudy and raining, the sky being sunny and this thing, and you arrive at a pretty um, general conclusion that it will not rain today because it's sunny. So that is sort of an inductive reasoning to this thing. And yeah, so And another example is that if sky is cloudy, it will rain, so you need to take an umbrella. That is sort of a deductive reasoning, because sky being cloudy, it may rain or it may not rain as well. So it is safe for you to take an umbrella. So from a general premise of the sky being cloudy, you are doing a particular conclusion that it will rain, so I'll take an umbrella. Sir, can you please explain syllogistic logic with example? So yeah, syllogistic logic with example is kind of so I mean, I hope that you already know what syllogistic logic is. So syllogistic logic is an Aristotelian way of deductive reasoning, in which he says that there is a particular grammatical structure to whatever reasoning we are doing it. So there will be a subject. Let's just say let's just take whales for example, uh, whales, and let's just say there is a predicament which is underwater. So all whales are underwater. Let's just take this as a statement, and all whales are underwater, and then we'll take another statement saying that no crab is a whale. So I'll just type it in the chat box as well. So all whales are underwater is one continuous statement, and then no crab is a whale. So both of these statements follow the Aristotle's rules for a premise, setting of a premise. So whale is the subject, and underwater is the predicament, and here crab is a subject and whale is a middle word. So an effective conclusion of whatever two statements this would be is no crab is underwater, which might not be true as well. Like the conclusion that you are getting from two true statements might not be true in some cases, but out of the possible statements that you are uh, getting from it, um, out of the possible statements that you are having, this could be one of the conclusions that you're getting. Like, so the, actually, a all no is actually not a Aristotelian structure, but I'm just giving you a general structure. You can also say that all crabs are underwater as well. So this might be true compared to no crab is underwater. All crabs are underwater is a much more true conclusion. But what syllogistic logic is saying is that all of these statements and these conclusions will have a certain structure. That is the bottom line of syllogistic logic. So whatever premise you are setting and whatever conclusion you are getting from those premises, those will have a certain structure. So if you are having a set of structures, those will have a middle word, a subject, and a predicament. And if you are having only one statement, it will have a subject and a predicament. Okay, I think it's already 3:30, so we will move on to the assignment portion of the week 2. As all, like as I said in the first part of the lecture, after the question and answer session, we will also have another doubt session till 5 o'clock. So I probably might be ending this assignment questions by 4:30 or something. After that, someone asked if we can discuss the week 1 assignments as well. We can go over them quickly in detail, but I'll also try to have a small doubt session after this. So whatever doubts you have after the question and answer session, you can ask as well. And I'll also repeat by saying that please let me know if some of these like you're getting some of these questions in your assignments as well, because last week I got some feedback saying that some of the questions that I discussed did not come in their assignments, And whatever answers that I am going to discuss, those might not be the official key as well. Those that is the key that I came up with. So the NPTEL might release another key which some answers may be different, and we can discuss that later as well. Yeah. So we'll start with the first question. So it is given that if copper is dipped in vinegar, then copper turns green. So they have given a statement saying if A, then B, and then they have given four options. If copper is not dipped in vinegar, then copper does not turn green. If copper turned green, then it must have been dipped in vinegar. If copper did not turn green, then copper was not dipped in vinegar. If copper is dipped in vinegar, then copper must turn green. So this I think is a multiple select question answer. That means that more than one option is correct. And Reba Lieben is saying answer is 3 and 4. Can you tell me why you think 3 and 4 is the correct answer?
Sir, actually, the concept is if A, then B. So the concept should go with if copper is dipped in vinegar, then copper must turn green. Then,
Okay.
then second one is if not B, then not A, where the third option can be matched, which means if copper did not turn green, then copper was not dipped in vinegar. This first option is that if copper is not dipped in vinegar, then copper does not turn green. But there may be other cases it might turn green if it is dipped. And the second option is that if copper turned green, then it must have been dipped in vinegar. So, if copper has turned green, it should have been dipped somewhere else and not only in specific vinegar. So, I think this third and fourth option may match to this question.
Yes, precisely. So correct options is option 3 and 4. So the options given in the like the four options given here are different deductive statements that can be concluded from whatever question statement that we have. So copper dipped in vinegar, then copper turns green is a question statement, and whatever four other options are there, those are the different forms of the same deductive statement that we have. And in recap, I told you that the deductive reasoning follows two different bifurcates into modus tollens and modus tollens. So if A then B is a question, then modus tollens tells you that if A then B, A is there, so in conclusion B should also be there. So if copper is dipped in vinegar, then copper must turn green, follows modus tollens. And what modus tollens says is that if A then B, not B is the condition. Therefore, in conclusion, not A should be a conclude. So, if copper did not turn green, copper turns green is B. If copper did not turn green is not B, then copper was not dipped in vinegar. Copper is dipped in vinegar is A, so not A should be, then copper was not dipped in vinegar. So this is a perfect example of modus tollens. So modus tollens and modus tollens are acceptable in deductive reasoning. So our options 3 and 4 will be acceptable. We will also discuss why 1 and 2 will not work. Yeah, same as Reba Levin said in the mic. So if copper turned green, then it must have been dipped in vinegar. That might not necessarily be the case. I can also paint it with green and saying that to copper turned green. So copper turning green is B, then it must have been dipped in vinegar. If B then A, then it's B then if B then A is not a correct way of deductive reasoning. So this option is not valid. And if copper is not dipped in vinegar, not A, then copper does not turn green. No, if not A, then not this is of the structure. If not A, then not B, and this is also not the correct answer because copper turn green in any other condition as well. It not necessarily be dipped in vinegar to be turned into green. So the correct option is if copper did not turn green, then copper was not dipped in vinegar. If copper is dipped in vinegar, then copper must turn green. Does anyone have any doubts with this question? We'll move on to the next one if not. Okay. I'll anyways for people who are joining late in this meeting, we will go through like I'll just quickly go through all the answers once again as well. This is just the discussion part of the answers. Yeah. So in the second question, the following statements are given. Statement 1, if the concentration of chlorofluorocarbons, CFCs in the air exceeds the threshold, then there will be a hole in the ozone layer. And statement 2 says that if there is a hole in the ozone layer, the large amount of ultraviolet radiation will reach Earth's surface. So already you can see that there is a pattern among the statements. So there is a form of a subject, chlorofluorocarbons, and then there will be a hole in the ozone layer. There's a sort of a verb, middle word, and statement 2 starts with the middle word of the first statement. So if there is a hole in the ozone layer, a large amount of UV radiation will reach Earth's surface. That is the predicament of the second statement, and that starts as the subject of the third statement. Ultraviolet radiation causes cancer. Yeah. So question is, what conclusions can you draw using valid logic if the following premise is also given? So they are giving another premise saying that there is an increase in CFC, chlorofluorocarbons, in the air beyond the threshold. So they are asking which one of these options will be valid. Does anyone have any answer for this? Okay, we'll go through the answers one by one. So there are three statements which are interconnected, and then there is a premise. And according to that, you can sort of connect all the three statements and connect the first word of the statement 1 to the last word of statement 3. So increase in CFCs, hole in the ozone layer. Hole in the ozone layer will large amount of radiation will reach Earth's surface. So this is also a form of deductive logic where if we have P1, P2, P3, P1 and P2 will form a conclusion, and the conclusion P1 and P2 will form conclusion 1, and the conclusion 1 with statement 3 forms conclusion 2, which is the final conclusion, or conclusion 2 and conclusion 2 with another statement will form conclusion 3, which will be the final statement, so on and so forth. So how much ever, regardless of how much ever statements that we have, the initial two statements will form a conclusion that along with the next statement will form another conclusion, along with the next statement, the next conclusion, and so on and so forth. So from the first statement and second statement, we can say that CFC increases, ozone layer hole, hole in ozone layer, large amount of UV will reach Earth's surface. So we can conclude from this that if the CFCs increase, a large amount of UV radiation will reach Earth's surface. This will be one conclusion. I'll just write in the chat box as well. CFCs increase, there will be a hole in the Earth's surface. This will be one of the conclusion. So take this conclusion in the chat box and then compare it with statement 3. CFCs increase, hole in the Earth's surface. Sorry, sorry. If CFCs increase, UV radiation will reach Earth's surface. If CFCs increase, UV radiation will reach Earth's surface. That will be the conclusion that you get out of statement 1 and statement 2. Now, take this conclusion 1 and statement 3. Ultraviolet radiation causes cancer. So, what will be the conclusion out of this? Conclusion of this. So, UV radiation reaching Earth's surface is a middle word. It is common for both the statements. So, the causative subject of the conclusion 1 and the predicament of statement 3 will form the conclusion. So, conclusion 2 will be if CFCs increase, it causes cancer. Sorry, causes cancer. I made a spelling mistake. Yeah. So now you can notice that if CFCs increase, it causes cancer. There are a lot of factors that come in between. ozone hole in the ozone layer and ultraviolet radiation. There are a lot of factors, but we are negating all of that and bringing a uniform connection to the increase in CFCs and causing cancer. And look at the last question now. There is an increase in the CFCs in the air beyond the threshold. So if CFC is increased, it causes cancer. Now CFC is increasing. What will be the answer? So if A then B, if A then B is a statement, conclusion, and then they are saying that A is there, so B should also be there. So the incidence of cancer has increased. That should be the correct answer. So the right answer would be the incidence of cancer has increased. And in this question, there is a hole in the ozone layer is also a correct answer because that is already conveyed through the statement. They already said in statement 1 itself, they told that in concentration of CFC increases, there will be a hole in the ozone layer. So they are just one of the answers is a direct implication of statement 1. The other answer is the connection of statement 1 and statement 3 to form a conclusion, and then using that to find a deductive logic. So I hope these are the two answers. Does anyone have any doubts with this? Death rate is increased cannot be an answer because there is no connection between CFCs and death rate anywhere in the statements as well as in the statement. There is a very small amount of ultraviolet radiation in Earth's surface is not a right answer because we already saw in the chat box that if CFCs increase, UV radiation will reach Earth's surface, because then if CFCs increase, UV cannot be low. So third option is also wrong. So first and fourth option will be the correct logical answer to this question. If there are no doubts, I will go on to the next question. Yes. So the next question is same, exactly the same. They have the exact three statements such as from the second question as well. So you can automatically come to in the chat box. I already said that if CFC is increased, it causes cancer. That statement applies to this question as well. The premise given here is different. A statistical survey showed that the incidence of cancer has increased. So we have A, if A then B, we have a statement that if CFC is increased, it causes cancer. If A then B, now they are showing that a statistical survey showed that the incidence of cancer has increased. So that is B. So if A then B, B is there. So they are saying what kind of conclusion can be drawn out of that. Automatically you can say that if B, then A is might or might not be true, because it does not follow modus ponens, or neither does it follow modus ponens, nor does it follow modus tollens. Modus ponens say that if A then B, A, therefore B. Modus tollens says that if A then B, not B, therefore not A. This, for if A then B, in this question we have if A then B, B, it follows neither modus ponens nor modus tollens. So we cannot conclude anything about A, anything about the levels of CFC. So this may look like a correct answer, but this is not a correct answer because we cannot make a conclusive, we do not have conclusive evidence towards it. There is a hole in the ozone layer that is also kind of going from reverse. That is also in this question. Um, in the statement 3, they are given UV causes cancer. They have cancer. Again, A gives B, B, so not A. That's not possible. So the hole in the ozone layer is also wrong answer. And there is a very large amount of ultraviolet radiation in the Earth's surface. Ultraviolet radiation is also same. If A then B, then B, not A. So all the three options are not valid. So the correct answer would be none of the above. Does anyone have any doubts with this? Yes. So basically, what we all the following, like right from the first question, we are following either deductive or syllogistic logic, and through we are just connecting all the deductive statement, all the statements together to form a deductive premise, and then we are connecting that with another premise to form a connection or to form a conclusion. And I think subsequent questions also deal with the same questions. So if people have already attempted this assignment in the NPTEL, you can let me know that you have, like you need not tell me that what answer you have chosen, but you can just let me know whether you get the same questions in that I am presenting now or not. Yeah, fourth question, same exact three statements as question 2 and 3, but the premise is different. The premise is that a statistical survey showed that the incidence of cancer has not increased. Vijay Mahantesh Patil, if I am correct, pronouncing it correctly, I am seeing the same questions in my assignment. Thank you so much, Vijay. Vijay, yeah. Okay. You can also let me know after I have completed all the 10 questions, so that it will be easier for me to give a proper feedback to this thing. Else I would have to tell the NPTEL team that different people get different questions. That's the only thing. Yes. So I'll move on to the question number 4. Question number 4 are the exact three statements compared to questions 2 and 3, and only the premise has changed. And all of the questions, if you observe, they either come back at you using modus ponens or modus tollens. So if you fundamentally understand the fundamental concept of modus ponens and modus tollens, all these three questions would be much more easier. So a statistical survey showed that the incidence of cancer has not increased. So now we have not B. So using modus tollens, not A could be a correct answer. So out of these four options, can anyone tell me what could be correct answer or answers? I mean, it's there is a incidence of cancer is not Vijay. So you are saying option 3, but observe one thing. So incidence of cancer is not increases, not B, but there is a very high amount of UV radiation on earth's surface. That is like, that is not A, that is A. So not B giving rise to not A is not a valid deductive reasoning. So 3 cannot be an answer. So if there is a not B, then not A should be a conclusion. And out of those 4 options, which one is saying no? Like there is nothing, or not increased, or nothing is. Okay. So out of these 4 options, I already given the reason for why 3 is not the correct answer. In the same way, option 1 is also not the correct answer, because for cancer not being increased, they are saying that there is an increase in CFC in the air. So not B giving rise to A once again cannot be a valid deductive reasoning. So this cannot be a correct answer. And in the second option, there is no hole in the ozone layer. Cancer has not increased, not B. There is no hole in the ozone layer, that is not A. So if you compare statement 2 and statement 3, you could come to a conclusion 1, like a pre-conclusion saying that if there is a hole in the ozone layer, it causes cancer. If there is a hole in the ozone layer, I'll just type it out in the chat box. If there is a hole in the ozone layer, it causes cancer. This conclusion comes out of statement 2 and statement 3. Yeah, if everyone can understand it. And in the premise we have, if so, hole in the ozone layer is A, it causes cancer is B, A causing B, and in the premise they are giving not B. So according to modus tollens, not A should be a correct answer. So the correct answer would be, there is no hole in the ozone layer. Does anyone have any doubts with this? Like as I said in the beginning of the question, all of these follow a specific pattern of like they either follow modus ponens or modus tollens, and the other wrong conclusions neither follow modus ponens or modus tollens, so they will not be a valid detective answer to the question. Okay, if there are no doubts, I'll go on to the next question. Once again. Yeah, question 5, exact same, follows the all the other um, uh, follows the same exact same rules such as questions 2, 3, and 4 as well. So all of them have the same statements. The only the premise is different. The premise here is that a measurement showed that the amount of UV radiation reaching Earth's surface has increased. So a measurement showed that the amount of UV radiation reaching Earth's surface has increased. So UV radiation. So what can UV radiation? The statements involving UV radiation is just statement 2 and statement 3. But statement 1 also can be interlinked, because statement 1 and statement 2 can form a conclusion as well. So they just wanted to know which one of these can be possible. So they are saying UV radiation has this question is MCQ radio button. So there will be only Vijay is saying this question for those of you who cannot read the chat box. Vijay is saying this question is MCQ radio button. So yes, this question is MCQ only. This question has only one right answer. So you just have to find out which answer is right. Actually, there is only one right answer in this question. All the other of them does not follow any other rule. And I mean, and if you follow logic, the logical reasoning, if you find one option to be wrong, then all of the above is also not right. So yeah, so amount of UV radiation reaching Earth's surface has increased. So let's just take this statement: UV radiation causes cancer. A causes B. A is there, so B should also be there. That is normal modest pollens. So incidence of cancer has increased is a correct option. So that would be the only correct option in this question. Then there is a hole in the ozone layer. If you want to address about the hole in the ozone layer, you would have to backtrack from the predicament towards the subject. So hole in the ozone layer causes UV radiation. There is a UV radiation. So if A then B, then B. B is there. It need not necessarily mean that A should happen as well. B could happen because of other factors as well. So there is a hole in the ozone layer is not a proper deductive conclusion. There is an increase in the CFC in the air beyond the threshold. This also. So out from statement 1 and statement 2, we can conclude that if the CFCs in the air exceeds the threshold, UV radiation will reach Earth's surface. Now UV radiation is there. It does not necessarily mean that CFCs in the air exceeds the threshold. As mentioned, UV can also increase by any other method. So there's an increase in CFC in the air is not a valid conclusion. So the only option here is incidence of cancer has increased because it follows proper modest pollens. So I think so all the questions from 2 to 1 to 5 itself follow proper modest pollens and modest tolerance and deductive reasoning. So from each one of them, each one of the statements you just follow meaningful conclusions. You stack statements together to form conclusions, and using those conclusions, using the conclusions and the premise given in the question, you just have to find whether each of those options follow modest pollens or modest tolerance. If they don't follow any of the, if none of the options follow modest pollens or modest tolerance, then none of the above would be the answer, like we saw in question 3. Yes. So we'll go on to question number 6 as well. So in question number 6, we have some particles have half integer spin. Sorry. So we have two statements. I think I didn't frame the question properly. Some particles have half integer spin, and no particle with half integer spin is a boson. So we have two statements, and what conclusions can you draw out of them? That is the answer. Can any one of you try to answer this question? It's a simple, just two statements. You just have to get a one conclusion out of it. Okay, if no one answer this, I'll just kind of. Yes. So this question can be solved using classic Venn diagram examples. So you have some particles have half integer spin. So we'll have just have a yes. So we have some particles having half integer spin, and then we are saying that no particle with half integer spin is a boson. So whatever is a boson that does not have a half integer spin. So yeah, so we have half integer spin, we have boson which is not connected to each other, and but these can be so but they have given some particles have half integer spin. So these are particles which have half integer spin, these are particles which are bosons. So what kind of conclusions can we draw from this? All bosons are particles? That cannot be a correct answer, because there are some particles which have half integer spin as well, and there are some particles which are not bosons. Yes, there are other particles which have half integer spin as well. So there are particles which are not bosons. So this is the correct answer, this is one of the correct answers. And some bosons are not particles. No, all particles are bosons. So the correct answer would be only option 2. There are some particles which are not bosons. Does anyone have any doubts with this? Some bosons are not particles is not a, like I would like to repeat that some bosons are not particles is not a valid answer, because there is no predefinite relationship established between particles and bosons. They haven't said in the two statements, they haven't said that all particles are bosons, no particles are bosons, some are bosons, some are not bosons. Like that, they haven't mentioned anything. Nor have they established any indirect relationship between particles and bosons. They have just said that no particle with a half integer spin is a boson. So if there are no other doubts, I'll just move on to the next question. Yeah, the following premises are given: all whales are mammals, some mammals are carnivores. So what kind of conclusion can you draw out of it? This question also can be solved using Venn diagram. So I'll just move on to solve the question. So we have mammals. We have mammals. All whales are mammals. So we have mammals. So we have mammals, and then under all the mammals we have whales, because the first statement tells us that all whales are mammals, and then some mammals are carnivores. So this is where we have to be a little bit cautious. So some mammals are carnivores. So we can have a carnivore under which some are yes. So we have carnivores. Under some carnivores are mammals. But is this the only way to represent carnivores? I just have a small question which I think some of you can answer this. So I all whales are mammals is a very clear statement, but some mammals are carnivores, that is a bit unclear statement. No, Mayuri Dongri is saying C, but before going to the answer, we'll discuss how we are coming to C or any other options in this thing. I mean, in fact, the options is C as well as some other options, but how are we coming to this thing? That's the trick here, because we cannot definitely say that carnivores are only mammals and carnivores are not males. So I can even draw a bigger Venn diagram which says that this can also be carnivores. Even in this case, carnivores also males. Carnivores coming under whales can also be considered as carnivores coming under mammals because all whales are mammals. So that's the trick to solving this question in this case. So all whales are carnivores might not be a definite answer because we do not have a clear relationship between whales and carnivores. Some mammals are whales. Yes, some mammals are whales are correct because if all mammals are all whales are mammals, some mammals are whales are is a correct conclusion because some mammals are whales, some others are not, and some carnivores are mammals. True, carnivores. I mean, if some mammals are carnivores, some carnivores are mammals. The inverse also holds true. In syllogistic logic, we have all, not, some, and some not. In all those cases, the inverse also comes true. So if some mammals are carnivores, some carnivores are mammals. This also comes true. Some whales are not carnivores. So here is where uh, we have to think a bit because these two options here, these two deal about these two deal about the relationship between whales and carnivores, and according to those two statements, there is no definite relationship between whales and carnivores. And that is the only reason why we cannot take these two options as correct. So the only correct options that we have here are some carnivores are mammals and some mammals are whales. Does everyone get this answer, or does anyone else have doubts with how to solve this? I would like to repeat saying that there is not a clear relationship between carnivores and whales, and that is why any statement regarding the relationship between whales and carnivores cannot be made. Whereas carnivores and mammals is defined, mammals and whales defined once again. That's why we can make conclusions out of this thing, and those also hold to be true because one of them is just applying syllogistic logic, and one of them is just it gives a direct relationship under the Venn diagram. Okay, if no one has any doubts, I will go on to the next question. So yeah, Mayuri Dongri got it. Okay. Question number 8. So question number 8 has 3 statements. So the first statement is a true conclusion can be derived from false premises. Second statement is a false conclusion cannot be derived from true premises. Statement 3 is the conclusion is true. So out of these 3 statements, we have to decide which one of this is holds true, which one of these options holds true. I think this is a multiple choice question, so only one of the options hold true. So for this question, I mean, more than trying to derive any conclusion from the statements, you could logically think what the answer would be by just reading the answer. So all the statement 3 states that the conclusion is true, but all the premises are false. That is not the case in all the cases. If the conclusion is true, the premises may or may not be false as well. So all the premises are false is not a correct option, and at least one of the premises is false. That is also not true. There are conclusions, there are true conclusions where all the premises are true as well, and at least one of the premises is out of the premises may or may not be true. True. All the conclusions need not be true. All the conclusions need not be false. So all the premises may or may not be true is a correct option. And at least one of the premises is true. We cannot say about that. All the every true conclusion cannot also be derived from false premises. That is the that comes under the truth and validity of the syllogistic logic. None of the above is not a thing because we already have a correct answer. So the correct answer would be all the premises may or may not be true for a true conclusion. So we'll go to question number 9. So yes, which of the following, according to Aristotle, is not a type of structure a syllogistic argument may have? So syllogistic argument, Aristotle's. So this question just deals with arguments. It's a very simple theory-based question. Everyone can get it, I guess. So which one? Options are every A is B, some A is B, no A is no B, some A are not B. Which one of these could be correct? It's a very easy question. Every, all, I mean every can be also be told as all, so all A is B. Mayuri Dongari says C, no A is no B. That is correct. No A is no B because, yeah, Namrata Sohani is also saying 3, no A is no B. That is absolutely correct. So no A is no B is the correct option because all the other arguments, all A is B is a valid argument in syllogism. Some A is B is also a valid argument. Some A or not B is also a valid argument. The other argument in syllogism is no A is B, not no A is no B. We'll go to the last question. When Edwin Hubble used Cepheid variables to find the distance to the Andromeda galaxy, he was using inductive logic, deductive logic, both inductive and deductive logic, quantitative inductive logic. So I would like to say that for this question, even I am a bit confused about the answer between two options, but I would like to hear from you guys. What do you think about is the answer for the question? I have, so this is a multiple choice question. It only has only one answer, but I think I am thinking of two answers. Either of the two answers could be correct. Reva Levan is saying answer C. Why do you think answer C?
One second. Just a second, sir.
Yeah, sure.
Because
if you are not comfortable, you can also type in the chat box.
Because actually in the class session, sir said like the scientist Hubble, he applied this deductive logic from inductive logic to obtain the distance related to this astronomy and regarding obtaining the distance to the particular star. So he mentioned the statement like he applied this deductive logic from inductive premise. So from that,
Exactly. So for this answer, I have both inductive and deductive logic as the first answer, but only inductive logic could also be an answer. Why inductive logic is because Henrietta Leavitt, Edwin Hubble uses Henrietta Leavitt's linear relationship logic between the pulsating stars luminosity and the periodicity of the stars. So that is so Henrietta Leavitt just fixes it for some stars, and then astronomers generate it for all the stars. So that is one form of an inductive reasoning, and deductive reasoning is how we use it to define the stars of the distance. How we use the Cepheid variables to calculate the distance between stars and Andromeda galaxy itself. So he observes specific Cepheid variables for stars, but he concludes that he concludes that all the Cepheid variables in together could be the distance from Earth to Andromeda galaxy itself, and not particularly to each star. So that is one form of deductive reasoning. So he uses both inductive and deductive logic. Does everyone get this answer? Okay. Yes. Okay. Okay. So we have discussed all the 10 questions. I'll just briefly go over the answers one by one. Yes. So first question, it is given that if copper is dipped in vinegar, so yes. So those who missed the yeah, Sweta Pushpa Soumeshri is saying that this part was covered under inductive logic only. But yes, this is actually a very valid point. That's why I said that. So the detective part of the calculation was not discussed properly in the session. The lecturer, as well as the content that was given in the first lecture, that described only how linear, like how the linear relationship, like it focused on how the linear relationship between the luminosity and the periodicity is, can be helped to extrapolate to the distance to the stars. But what he also mentioned that, so that's what I said by the second part. So he was able to find specific Cepheid variables for each star present in the Andromeda galaxy, but he used that to generalize and give it a specific particular distance from Earth to Andromeda galaxy. So that's why I am saying that it also uses deductive reasoning. So he uses like general Cepheid variables getting from all the stars, and he was able to give it a particular distance to Andromeda galaxy itself. The lecturer didn't outright mention that it's deductive logic as well, but yeah. And once again, I'm saying that this is not the key that I am. This is the key that I am giving, and not the key given by NPTEL. So it may also be wrong. That's why I'm saying that just inductive logic can also be a right answer, and I'm pretty unsure of how to arrive at the right answer for this. Maybe we can post this question in the NPTEL discussion forum in Google groups, and maybe we can, someone else can also properly answer it. Maybe the other TA can also answer it. Anyways, so I'll just go over the questions one by one. So question number 1, it is given that if copper is dipped in vinegar, then copper turns green. So the correct options for this are, if copper did not turn green, then copper was not dipped in vinegar, and if copper is dipped in vinegar, then copper must turn green. Options 3 and 4. Option 3 follows modus tollens, and option 4 follows modus tollens. So in 2, from 2 to 5, the statements are the same. So I just read the statements for question number 2 alone. So the following statements are given. Statement 1 says, if the concentration of CFCs in the air exceeds the threshold, then there will be a hole in the ozone layer. Statement 2 says that if there is a hole in the ozone layer, a larger amount of ultraviolet radiation will reach Earth's surface. And statement 3 says that ultraviolet radiation causes cancer. What conclusions can you draw using valid logic if the following premise is also given? So the premise is there is a increase in CFC in the air beyond the threshold. So the correct options for this is, there is a hole in the ozone layer, the incidence of cancer has increased. So there is a hole in the ozone layer comes directly from statement 1's statement 1 and premise is also almost the same. So the hole in the ozone layer is a valid conclusion from statement 1. The incidence of cancer has increased as a combined conclusion from all the 3 statements and the premise. So question number 3, same statements as question number 2, but the premise is a statistical survey showed that the incidence of cancer has increased. So the correct option is none of the above, because none of the options follow either modus tollens or modus tollens. And question number 4, same statements as questions 2 and 3, but the premise is a statistical survey showed that the incidence of cancer has not increased. So the correct option for this is there is no hole in the ozone layer. So this follows modus tollens between statement 2 and statement 3. So statement 2 and statement 3 forms a conclusion, and the conclusion and the premise given in the question form two statements from which we can get modus tollens. By use of modus tollens in deductive reasoning, we can conclude that there is no hole in the ozone layer. None of the other options follow modus tollens, so those are not valid options. And question number 5, once again, same statements as questions 2 to 4. The premise is a measurement showed that the amount of UV radiation reaching Earth's surface has increased. So the correct option is the incidence of cancer has increased. So this is modus tollens. Modus tollens between statement 3, modus tollens between statement 3. Others try to follow modus tollens between statement 3, statement 2 and statement 1 but are not successful. Question number 6 is, so there are two statements in this question. Some particles have half integer spin, and statement 2 is no particle with half integer spin is a boson. What conclusions can you draw out of them? So the correct option is there are some particles which are not bosons. The other all bosons are particles is not possible due to the Venn diagram that we have drawn, and some bosons are not particles is also a valid not a valid option due to the Venn diagram. The following question number 7, the following premises are given. One premise is all whales are mammals. The second premise is some mammals are carnivores. So there is out of these two premises there is no definite connection between whales as well as carnivores. So whatever relationship that are between whales and carnivores cannot be a valid option. And there are the correct options therefore would be some carnivores are mammals and some mammals are whales. So because through the Venn diagram there is no clear option between the carnivores and whales, so we can draw the Venn diagram as much as we want. Apart from that, we can have these two options as definite conclusions. Statement 8 has three statements. Question 8 has three statements. A true conclusion can be derived from false premises. A false conclusion cannot be derived from true premises. Statement 3 is the conclusion is true. So the correct option is all the premises may or may not be true, which is logically true. All the other options are not logically true as well. All the premises being false and at least one of the premises being false. And Aristotelian argument for syllogism. So syllogism has four arguments: all A is B, no A is B, some A is B, and some A is not B. So the correct option is no A is no B is not an argument. And the last question, when Edwin Hubble used Cepheid variables to find the distance to the Andromeda galaxy, he was using both inductive and deductive logic. But in this case, inductive logic could also be a correct answer. So now that we have discussed all the questions, answers for the 10 questions, I'll once again open the room for doubt session. And some of you asked if um, we want to discuss the answers for week 1 as well. Should we do it now? Like, are the people still online? I'll repeat once again. So after the discussion of answers for week 2, some people also asked for discussion of answers for week 1 of the assignment questions. Should we discuss it now or yes, we can. I have asked for a week 1 question discussion. Okay. So, okay, we'll go to week 1. But before that, I'll once again ask you people, now that we have went over all the 10 questions in week, now that we have went over all the 10 questions in week 2, I wanted to ask you if, like, the people who have attempted the questions in week 2, do you guys also get the same questions in your assignments as well? Yes. Yes. Okay. Cool then. That's all I need. So I'll just stop presenting this slide for now. Same 10 questions, okay. Then it's fine. Okay. So I'll just stop presenting for now. I'll just open the other PPT. Just be online for a bit.
Sir, just one doubt.
Yeah,
Is
sure.
it the right time to ask?
Yeah, yeah, you can ask. You can ask now, or you can ask after we are done discussing the answers as well.
Okay, sir. Shall I ask it now?
Yeah, yeah,
Is it
sure,
okay?
sure, sure.
So actually, in the first two sessions, while I was attending this class session, sir mentioned so many scientists' name and the experiments they conducted. So, is it necessary to study all the terms and everything? Can we expect questions from the scientist's name, the years, the period in which it was conducted, and the experiments
No, no, no.
that was discussed?
That may not be necessary actually.
Okay.
Maybe so. According to what I have been going through in this course, so there are a lot of references to Aristotle because Aristotle found majority of the philosophical concepts that we're discussing with respect to scientific research.
Okay.
So the lecturer will be mentioning Aristotle's name in a lot of topics, but they will not be necessarily be for example, you might have got one question of like the only question you got in week 2 is about Hubble,
Yeah.
what kind of reasoning that Hubble mentioned. So that kind of questions you can actually go back to the material and as well as check it. Or you might also have transcripts and notes of whatever week's lectures have you have seen through. So that is pretty much enough for you to go through. I don't think it will come. Those kind of questions might come in the end exam because uh, the final exam will have a compilation of all the 12 weeks' materials as well. So I don't
Okay.
think we would be asking anything about like asking scientist's name and year and all those stuff.
Okay. Thank you.
Okay. Okay. So I've just opened. Can you all see my screen for week 1? Yes. Okay. So this was the presentation that I went for week 1. Pointer options. Yes, sir, pointer. Okay. So we'll start with the assignment questions for week 1. So question number 1 is, do you want me to discuss all the questions, or do you just want to go over the answers? I mean, I'll anyways take a minute or so to go over all the each question. So I'll do that. Yeah, brief discussion. Okay. So I'll just go over a short. Yeah, the attributes of truth are that it is 5 options: unique, absolute, relative, plural, and concrete. And out of the 5 options, so we know that science is not truth is not absolute because let's just assume that a person finds something about something one day, and then after let's just say a week or 10 weeks or even a year, some other scientist find performs any advanced sophisticated experiments and then finds that that is not true, something else is true about that. So what happens is, whatever the second scientist found out, that will be the truth after he found out that. So truth cannot always be same at all the points of time. That is what they mean by absolute truth. So in science there is no absolute truth, and science cannot also be plural. For one question, there will also always be only one answer. There can be many causative agents for that answer. There can be factors for that answer, but uh, question might not have plural answers, multiple answers. Yes, Reba Levan is correct. So the options are 1, 3, and 5. Truth will be unique, relative, and concrete. Yes. Absolute and relative are almost opposites in this context for this question. So truth is always relative. Truth always keeps changing, and truth is always concrete. So there is no ifs, buts, and maybes in an answer for scientific question. It is always straightforward. So that is what it means by concrete, and truth is always unique. So the position of second question, the position of idealism is that everybody should have an ideology. Idea is prior and matter is secondary. There are non-material entities in the world. Matter exists in our consciousness. So everybody should have an ideology is completely different. That does not necessarily mean idealism. Idea is prior and matter is secondary. Of course, that is the core principle of idealism. And there are non-material entities in the world. Yes, compared to materialism, which says that everything is matter, idealism says that there are also non-material entities which cannot be explained, like ghosts or apparitions or something like that. And matter exists in our consciousness, and which opposed to materialism saying that matter is everywhere. Matter does not exist in our consciousness alone. Yes. Now moving on to the third question. The position of materialism is that matter exists independent of our consciousness. Eat, drink, and be merry should be the motto of life. The world is composed of matter and nothing but matter. Matter is the way we see it. So, does anyone know the answer to this? One and three, yes, almost correct. Yeah. So, we just saw from the previous answer that idealism says that matter exists only in our consciousness. Materialists say just the opposite. Matter exists independent of our consciousness, and materialists' core philosophy is that everything is matter. World is composed of matter and nothing but matter. Eat, drink, and be merry is just a spare option. Matter is the way we see it is also not a correct answer. Okay. Fourth question, the method of science rests on subjective idealism, objective idealism, subjective materialism, and objective materialism. 4. Reba Levin is saying 4. That is the correct answer, objective materialism. So we know for a fact that modern science rests on materialism. Modern science does not believe in the fact that there are unexplainable things, which idealism says. So materialism, anything other than materialism, so whatever that has idealism is automatically ruled out. Subjective materialism, objective materialism, and modern science also based on objective truth, not subjective truth. So correct answer is objective materialism. Okay. Which one of Mill's methods did Becquerel employ to conclude that the presence of potassium uranyl sulfate is the cause of radiation? I think this is a multiple choice question. Only one answer is correct. Vijaya is saying 2, method of agreement. Yes, that is the right answer. Can anyone explain why the method of agreement alone? Either by chat or by mic. Okay, I'll say. So, what Becquerel basically did was he had different sorts of potassium, uranium, and he had different sulfate salts, and then he tried to check the radiation in all of them, and then he found out that only uranium-based salts was emitting radioactivity. Uranium was a common element, so he found out by method of agreement that that's the cause of radiation. Method of agreement basically says that if there are multiple factors and one factor is common in all of those cases, then that's the causative factor of the effect. Okay, so which were the four causes behind any event as proposed by Aristotle? 4. Yes, 4 is the correct answer. Material cause, formal cause, efficient cause, and final cause. So one of them is the agent, one of them is the idea itself, one of them is the material, and then one of them is the final objective. So material cause, formal cause, efficient cause, and final cause. So 7th question, Hume's criteria of causality were Okay. So, okay. No, no. Vijay is asking if 2 is the correct option. 2 is the correct option. Precedence, contiguity, and constant conjunction. So, precedence just means that if A causes B, then A should always be before B. So, A cannot be after B. Contiguity is that if A causes B, then A and B should not be far away. They should always be closer together. And constant conjunction means if A causes B, A and B should happen simultaneously. They should not be happening after a period of time. So precedence, contiguity, and constant conjunction is the uh, correct option. There are, I mean, I think there is a way, pretty, so wherever concomitant variation is coming, I think you can just uh, remove that option, because concomitant variation is from John Stuart Mill. John Stuart Mill, or yeah, John Stuart Mill's methods, and then agreement is also from John Stuart Mill. So the only option is precedence, contiguity, and constant conjunction. I think this is the kind of question that Rebal even also asked in the question, whether do we have to remember certain scientists' way of, these kind of questions might come. So as Rebal even asked earlier in the Dow session, so what did Hume do, or what did John Stuart Mill do? You might just have to kind of keep in mind what these kinds of people did, and not confuse it with other people. Yeah, I don't think there will be a lot of memorizing. It would just be in the final exam anyways. It would be just common sense. These kind of questions are asked because you can anyways refer back to the material and answer those questions. Question number 8. John Stuart Mill's methods of ascertaining the cause of a phenomenon or event were. Yeah, this is also whatever wrong answers were there in the last question are the correct answers here. So, concomitant variation, agreement, residues, and difference. That will be the correct answer. Third option. And whatever. I think constant conjunction in fourth option, precedence, and then contiguity, constant conjunction, all of them will be wrong. Yeah, third option is the correct option. Ninth question is, what is the philosophical concept of matter? Matter is anything that has mass and occupies space. Matter is anything other than energy and radiation. Matter is anything that exists independent of our consciousness. Matter is anything that is knowable. Yes. So the correct answer is, matter is anything that exists independent of our consciousness. This is according to materialists. Okay, Vijay is saying confused between 1 and 3. Matter is anything that has mass and occupies space. So, you must be like, so when you are confused between this first option, you must go to between, so materialists and idealists were arguing about the position of matter in scientific research, but both of them had one specific uh, meaning for matter, which is anything that exists independent of our consciousness. And since we employ materialism in our modern science, the materialistic way of matter that exists independent of our consciousness is would be more correct. Rebal even is saying according to physics 1. Yeah, I mean, in general, anything except 2, in general, anything except the second option is acceptable, because matter is anything that is knowable, and matter is anything that has mass. And so, because matter is anything that is knowable, because everything, like, there is no unexplainable things in scientific research. Therefore, matter is anything that is knowable as well. That is also a correct option as well. And matter is anything that has mass and occupies space is also correct. But according to the definition of matter during the debate of materialism versus idealism, the third option stood out. Matter is anything that exists independent of our consciousness. Okay. Last question. What is the cause of the growth of a seed into a sapling? Existence of water, air, temperature. Fourth option is A, B, and C individually are causes. Fifth option is A, B, and C taken together is the cause. Reba is saying answer is everything taken together. 5. Yes is the correct answer, because we saw that an effect has only one cause. An effect cannot have multiple causes. In that cause, there can be multiple factors, which are the first three options: water, air, and temperature. Those are individual factors combining to one cause. So that singular cause causes an effect, that is the growth of a sapling. So that's all. I think that's all the 10 questions that I have in week 1. So we have 20 more minutes remaining before the end of the session. So I'll open the doubts room for another 10 minutes so that you guys can ask questions. If not, we can end the session after at 4:50. Yeah, thank you so much. You can also yeah, this this 10 questions were the one which I had some problem with some people, because some of them said that those were not overlapping with the questions that they got in assignments. So that's when I thought maybe different people get different assignment questions and I can't discuss everything with them. So that's when I thought of actually changing the way that this TA-ship session can be held. Like, instead of me giving the questions, you guys can give the questions and answers, and we can discuss the things if the questions are different. I guess some people are joining even now as well. So I'll just briefly tell what we have gone through. So in this TA session, we just went through. So in this TA session, we just went through. We started with the recap of all the lectures in week 2. We started with logical reasoning and how it is bifurcated into inductive and deductive logic, and we saw into probabilistic and deterministic logic and syllogism, and the four arguments of syllogism proposed by Aristotle. And then we went on to discuss the answers of assignments from week 2 as well as from week 1. And yeah, now we are sitting here for the doubt session. Reba is asking, can you please explain this 4 methods of John Stuart Mill? So okay, so John Stuart Mill's 4 agreement, and some confusion between agreement and difference. Okay. I'm assuming that you know what are the 4 methods. So methods are concomitant variation, agreement, difference, and residue. So in concomitant variation, what John Stuart Mill is saying, that if, let's just say that A causes B, if A increases and B increases, or if A increases and B decreases, there is sort of a causal connection between both of them. And that's how we can say that because A changes and B changes, there is a causal connection, and that's how we can say that A causes B. And in method of agreement, so in a method of agreement, B happens. But John Stuart Mill says that let's just not assume that A causes B, but B happens, and there B happens under a lot of conditions. So let's just say that yeah, let's just take the example of potassium uranyl sulfate. So Becquerel and Marie Curie performed the experiment of radioactivity of potassium uranyl sulfate. So they wanted to know which of one of those elements caused radioactivity, if potassium caused it or uranium caused it or if sulfate caused it. So they took different salts of potassium, different salts of uranium and different salts of sulfate, and then they checked the radioactivity of each of the salts, and they were only able to confirm radioactivity in uranium based salts. So they performed experiments in different conditions, but in all of those conditions where the experiment was successful, where radioactivity was found, only factor A was common. Only the factor of uranium was common. So whatever common factor causes the effect. So that is the method of agreement. Something else can cause as well, but for the sake of agreement, they are saying that this factor causes this thing. And method of difference is simple. If A is not there, whether B is happening or not, that is the method of difference. So let's just say that if a, a different part of performing the same experiment is take potassium uranyl sulfate and take potassium and sulfate which doesn't have uranium. So if without uranium, if there is no radioactivity, then we can say that uranium causes radioactivity. So both the agreement and difference experiments are almost similar, but the way they do it is different. One is taking all the conditions. In difference, they just negate the absence. They just take the absence of the causative agent into condition. And the other one is residue. And then residue, they were like cos A, cos B, cos B, cos C gives an effect. So they just keep on negating one, and then they find out that this only one there is only one cause remaining. So they can't find any evidence for that cause, but because there is only remaining out of the all the other causes, so they just take it as a cause. Where do we have recorded video for second week problem solving session, sir? Uh, Karthik, so this is the second week problem solving session. So once this session ends, this will be uploaded into NPTEL. So right now, like for the past 1.5 hours, we were discussing the second week's problems. I hope it's clear. We still have 10 to 15 minutes of doubt session. So if anyone else has any doubts, you can ask. Sweta Pushpa Soumyashri is saying, sir, can we have a live session too for another date and time? So I think someone asked this last. Our live session are clashing. Can you explain in detail? Like I don't get how your live session are clashing. So I'll just explain this as well. So this course, research methodology in natural science, I am taking 4. Oh, okay. So okay. So it's totally fine actually. So what I would like to say is we have for this research methodology in natural sciences we have two TAs. I am one of the TAs, and there is another TA called Uditya Saha. So if you go to the NPTEL, like I think you will also be getting mails from TA ship for TA sessions. When are the sessions happening? So since this slot is not fixed by me but by NPTEL actually, so I cannot change the slot all by myself. Except for like if I have to take a session in March, maybe I might have to ask NPTEL now for changing. So what you can actually do is if this time slot does not suit you, maybe you can consult the other TA and you can maybe try attending a session. I think his session is on Tuesdays from 5 to 7 or something. I am not sure about when his TA session is, but you can try going there and yeah. If try saying that if that TA session works for you. Yes. Any other doubts? We still have 5 to 10 minutes of doubt session. I'll just leave the room open for 5 minutes for any other questions. If not, if no other questions are there, we can end the session by 4:45. Thanks.
Sir, I have one doubt.
Yeah, sure.
So regarding the question paper pattern, so should we be prepared for some paragraph based answers, like should we answer anything in paragraph basis? Will there be questions like that for this one particular subject, or can we expect only MCQ pattern?
I am not sure about that.
Okay.
You will be definitely you will be getting MCQ and MSQ, multiple choice and multiple select based questions. I am not
Okay.
sure you will be getting essay based questions, but I don't know in how what way you will be getting essay based questions from this type of subject. Yes.
Okay.
So and one other thing is that whatever pattern you will be getting in assignments is whatever pattern you will be getting in exam as well.
Okay.
Yes.
Yeah.
So if you are not getting essay based questions in the assignments, you will not be getting essay based questions in the exam as well. That is, I mean, I think that applies common through all the NPTEL courses.
Okay. So
Yes.
thank you.
Yes. But anyways, the some people are saying that exams on April 27th. So I think 1 or 2 weeks before that you will be getting an exam pattern if I'm not wrong. Let's see during the time if something changes. Karthik is asking if all A is B, then how is that some A or B as a possibility, sir? A little confusing. Can you, okay, if, can you explain, like, can you explain in detail? I'm not getting the question. So I think you are answering about this thing, Aristotle's arguments of syllogism, if I'm not wrong.
Good evening, sir. Yes, sir. It's Karthik here. It is the premise is given actually. If all A is B, and when it comes to Venn diagram, some A are B. So when the premise itself it says that if all A is B, then why is that we have to categorize as that like some only some A is B? Then that is a little confusing. I thought.
Oh, in the okay, in the Venn diagram. Uh,
Right.
I mean, so it's a so okay. I'll just try to draw it over here if possible. And so let's just say we have B, and then let's just say we have A. So I mean, according to this Venn diagram,
Right, sir.
we have all A is B. So I mean, that is So I kind of get your doubt. So when we say all A is B, then how some A is B is also a possibility. But that is the way that um, that is the way that they can also like, so that is also a possibility. So some A is not in this case some A is not B is not a possibility.
Exactly, exactly. When some A is not B here, because right from the diagram itself, we can say like
Yeah,
everything belongs to B. All of the A belongs to B. Then why is that we specifically have to say some A is B
I
there?
mean, so the way I see it, so let's just kind of divide this into two. Yes. So this is like some A, or like let's just if we just divide A into two parts, we have
Okay.
like half of A would be some A. That some A is also part of B. That's what they are trying to say. So I guess you have also tried to come across this Venn diagram notations where you might have studied about A union B and A intersection B.
Right, right, sir, right, sir.
Yeah. So in those Venn diagram notations, you will say that if A union B is if A is inside B, if A is a subset of B, then A union B is equal to A intersection B. The same thing goes for this uh, diagram as well, this notation as well. If all A is B, then some A is also B.
Right, sir. Thank you, sir. Thank you.
Sure.
And this session will be uploaded, right, sir? I mean, in the
Yes. Yes.
Google
Yes.
Sheet over there.
Yes. Yes. I'll send this to NPTEL and they will put this URL over to the Google Sheet that you are getting.
Right.
Okay.
The assignments will be like has to be submitted before 7th. So
Yes.
just think.
I think week one and week two, if I'm not wrong, should be submitted before 7th. I
Yes,
don't
sir.
know exactly. Yeah. Okay. Both should be submitted before Feb 7. Thank you so much. Yeah. Any other doubts? We have 4 more minutes till we close the session. Okay, then if there are no other doubts, I'll end the session. End the session. But if you have any other doubts after this, you feel free to post the doubts either in the Google Groups discussion. Like I think you all of you have got the link for the discussion forum in Google Groups for this course. So feel free to post any doubts over there. We are obliged to me and the other TA and even if we have NPTEL based doubts, the NPTEL team is also ready to answer those doubts, and the faculty in charge will also answer those doubts if he is free. So there are 4 different venues for answering those doubts, whatever doubts you're posting in the discussion forums. Can you give the group URL here? I am not having it right now with me. I might have to search for it. So I think it's available in the NPTEL website itself. So I think it's under ask a question or something else. Yes, extremely sorry for uh, I can't give you the URL right now. Because I wanted to search for it. Yes. Yeah, so that's the thing. So feel free to post any doubts over there. We have a week's time before the next TA session as well. And if you have any general or long doubts, you can always approach me during the next TA session, which will be every Saturdays from 3 to 5. So that's about it from my side. So thank you all for attending. I'll see you guys in the next Saturday, 3 to 5. Thank you.